Hey guys, welcome back to Zira Networks, your favorite channel. Ukeme is my name, and I love having you people here. If you are first time passing through this channel, subscribe so that you can get more. We'll talk about everything renewable energies and everything. So today, I want to. It's a very different topic: how to protect your inverter. So today we're talking about protections, protective devices, and the funniest thing is that in your system, in your whole inverter installation, the only thing that is so vulnerable is the inverter itself, because the inverter is the heart of the system. Your battery is being protected already by the inverter because it's connected to the inverter. So the BMS, they communicate. That's where communication between the battery, if you're using lithium battery. But if you're using lead acid battery, no worries. So how do we protect our system? Most inverters are 5 years, 10 years, and others are 1 year, 2 years warranty. But do you know that your inverter can last even up to 10 years? The inverter I'm using in this office, it's clocking 5 years. So now I need to let you know why and what you're protecting against. And if you can protect against those things on the display, you're good to go. You see those five things, if you can successfully protect your system, or if you're, because if your source of energy, I'm talking about your AC source, your grid, if it's that clean to take care of those things, nothing will happen to your inverter. Because most of your inverters, they have their inbuilt short circuit. So if you join positive and negative together, those new modern inverters, they will shut down. And most of them will communicate with you by giving you error codes. But these ones, you need to take care of them. What are those things that we're about to show you how to protect when it comes to your inverter? Let me quickly run through them. It's here. High voltage, you need to protect. Some inverters now that they have all those things inbuilt, but most times you need to put it the external ones. You don't really rely on what most of the inverters will say. Will protect against us, will protect against us. Put your protection. I always tell everybody, all your installations, put your goddamn protection. So high voltage, low voltage, surge, enemies to inverter, spikes, frequency, and harmonics. You can read about those things. If you are able to protect your inverter from all those things, your inverter might last for even 20 years. So, what are the devices we're talking about? For this is what I normally use. I love using them, so I make sure I'll open all of them so you can get to see the inside. So this is my DC protection box, so you can see SPD, you can see breakers, and it all comes with fuse. I don't joke with protection, so that's why some of our systems, 3 years, 2 years, zero maintenance, and clients will always like calling us back. So, and this is for the AC. You can see the fuses here. So your surge protector, very important. AVS, automatic voltage stabilizer, you set it. Your bypass, and the breaker. I will explain all those things and what they do one after the other. But before then, let me open them and see, so you can see, take a look on the wiring inside. This box is IP65 protected, but we normally mount it indoors. Okay, so this is what the inside looks like. This is just to make your work neat and your work. So I'll do the same here. So easy peasy. So these are the protection devices I'm telling you about. So how do you protect your system? During your inputs, these are very important. First of all, let's talk about high voltage and low voltage. If the voltage is too low, it will affect your system. If the voltage is too high, depending on the tolerance of the inverter, the make of the inverter you're using, if it's too high or if it's too low, it will affect your system. So some inverter has what they call derating. So you now see that it's dropping the power, the output energy. They'll tell you derating. Read about it. It's because the energy is too low. Most of your inverter, once the voltage drops below 160 volts, European standard is 220, 230 volts. Here we are making this video, we use 220 volts, 50 hertz in terms of frequency. So to do that, some people introduce a automatic voltage regulator that monitors and keep it steady, but it makes the work because they're very expensive now, and you're trying to set up a system with very minimal maintenance. But in that case, low voltage, high voltage, this AVS takes care of it. So what we do in Zero Networks, we set the input voltage to a range of, remember I said we use 220 volts here. So we set the input voltage to once it's 200 volts, the system cuts and you're being transferred to solar and battery. And once it gets back above 200, it's the same thing. For the case of high voltage, we'll leave this maximum 240 volts. This will shut down. So this alone, all it does is to put a limit between the low 200 volts and the high 240 volts. So having hit this in the system, it's number one protection for your inverter and your entire solar installation system. Then the second one, these are just breakers. So I will not talk about breakers because we all know what breakers do. MCB breakers, what they do is to break the current, to break the input or the outputs whenever there is need, and to take care of overcurrents. So you size your breakers according to the rating of the inverter. I will do another video that will take care about current sizing and all those stuff. So we then move. This is surge protector. You know, the next thing we spoke about was surge. And we always make sure you have your SPD installed along your system. This is a surge protective device, surge protector, SPD. What it does is the simple way it operates and the simple way it works is this monitor, so you can see live, you can see neutral, and you can see earth. So it monitors the two lines, the live and neutral. So if it's a three-phase system, you have all the lines. So you now have four terminals. So it monitors all the lines and compare. Once there is a spike, once there is an increase, the excess is being drawn to the earth. So that takes us to another protective step is your earthing in your house. Always make sure you earth your inverter properly, because if your earthing system is not standard, it's not working well, it will affect all those. Putting those surge protector will just be like you're just leaving a popcorn here. It won't actually work because it needs a proper earth for this to work and protect your system. So we've spoken about the AVS, automatic voltage stabilizer. Then we've spoken about the surge protector. Then we'll now move out to fuse. Some inverters are not designed with a short circuit function. So what we do is, if by chance there's a short circuit in the installation, this fuse will take care. And if you draw more than the rating of this fuse, so you use this one to control the source that gets into your house. So that's fine. So this is an AC control box that takes care of all the protective devices are here. You connect it properly. This took time to arrange. You can actually get any box and do it yourself if you know exactly what you're doing. Now, when you're done protecting your source of alternating voltage that comes into the house, now you have solar panels installed. Most systems are grid tie, so you need solar panel. You cannot just connect your solar panel straight down to your charge controller. You need to put a breaker of correct sizing and rating, so that in terms of maintenance, if you want to work on it, always put it off and on. And also, you need a breaker that will monitor. You need to still put surge protector. And most times, I encourage that you put fuse according to the size of the panel you're using. Always put the fuse between your solar panel. They should be fused so that for protection, it can easily cut off. And getting all those fuses easy peasy, is very cheap. Fuse is cheap where I'm making this video. I don't know about your location. And see, this is a 15 amps. The panels I intend to use, maximum is 14 amps. So this can easily break out in terms of trouble. Then remember, since this box, it's a two-way in, I'm connecting two strings, two-way in and two-way out. So I put equal breaker here, surge protector. This one is DC, SPD, surge protector, and a breaker here. And don't mind me, I like putting fuse even on the neutral line. But if you put fuse on the positive line of your solar panels, it's fine. I like being out there when it comes to protection. So this is for the DC. So if you are doing installations, when you have your DC coming from the panel before, if you're using a hybrid system, if you're using a non-hybrid before your charge controller, you get this protection sound. And you do this for your inputs of your AC, that's alternating currents, that's from your grid, your national grid, your whatever light you're using in your country. You put this. And the next thing is always make sure you put a circuit breaker of correct rating and sizing between your installation, between your inverter and the battery you're using. Once you do that, your system will be top-notch protected. So now you now protect your system from high voltage, low voltage is taken care of, surge is taken care of. That's the function of this surge protective devices. Then frequency, harmonics, most inverters have control over that. So that will be inbuilt. So thank you for watching. And to do this work, to support this work, kindly click like and subscribe. And if you enjoy the video, always watch out for new videos. We'll be giving you what we learn and what we know. Remember, our channel is just to teach you how to do your DIY if you're into solar or if you even have passion for solar. Thank you. Ukame is my name once again. See you next video.